This video is going to focus on how we use significant figures to properly round our numbers when we calculate with measured numbers. So in the first place in chemistry, we have to make sure that when we report our numbers, you report them to show what's measured. Okay, and that's where the significant figures discussion comes from. Now, the problem is if you use a measured number in math to do something, the number you report also has to show what is measured and what's not measured. Now, obviously, the end result of your math is not a measured number. You can go in lab and measure your answer, but it's based on measured numbers, so it has error in it, and you want to be able to report to someone how good your answer is based on how precise your measured numbers were. Okay? If you report too many final digits, they think your measurements were more precise than they were. If you don't report enough, then they don't trust your number. It's just a way to figure out how to show how good your numbers were to begin with. There are two rules. One rule for multiplication and division, and one rule for addition and subtraction. The nice thing is the multiplication and division rule is very simple, and we mostly multiply and divide in chemistry. The addition and subtraction rule is something you will learn, you will apply, and then you will forget, and we'll have to review anytime you add, because we hardly ever add. Here are your two rules. I'll show you examples, but these are the rules. Okay? Again, the question is, I have done a math problem. I have an answer. How many digits do I write down? And the number of digits depend on how well your numbers that you used for the calculation were measured. So if you are adding or subtracting, the answer you report should be rounded to the same precision as your least precise measurement. Super confusing. I'll show you what this means. Okay. A little bit that you can understand. Remember when I talked about precision of instruments, I said the more precise instruments are the ones with more digits. So your least precise number is your number with the least number of digits, but not the one that only has like 2 digits and this one has 5. I mean the least well known. So it has a number in the ones, but not the tenths, okay, or something like that. The rule for multiplying and dividing is that your answer should always have the same number of significant figures as your least well-known number that you use in your calculation. So this is actually, you don't look at how well-known the number is in terms of its places, you just count. If you multiplied two numbers together and one has 3 significant figures and one has 4 significant figures, your final answer should be rounded to 3 significant figures because that is the lowest number of significant figures you have in your problem. So as I said, significant figures don't go away ever. You're going to do all the math in here, and then once you finish, you will run back through your problem, calculate your significant figures, and round your final answer. It's always 2 steps. Do the actual math, and then figure out how to round. So let's look at what the rules look like. For adding and subtracting, again, it's that you round to a location based on how precise your measurements are. The number that is the least precise, which means it has the least number of digits going from left to right, is where you round. So here's an example. If I take these 3 numbers and add them together, I get this. But that is not reported correctly. I need to round my final answer based on the least precise measurement that I just used for the addition, in which case I would round to the tenths. That is like my number that is the least precise. Because that's my least precise number, it dictates how I can report my final answer. So you would round to the 4. Now, regular rounding rules apply. So if I'm going to round to the location where the 4 is, I'm going to look at the number behind it, which is a 2. If it's a number less than 5, you would not round up. If it's number 5 and more, you would round up. So here's another example. If I add those 3 numbers together, I get this. Okay. That is not the correct answer because it's not rounded based on sig figs. So you need to round your final answer to the tenths. But in this case, when you look at the number behind the 7, it's a number 5 or greater, so you'd round that 7 up. 2 and 8. Okay, this is a subtraction one. It's the same thing. You subtract. This is not the right answer. It's not rounded correctly. You round to the hundredths. That 6 would tell you to bump your number up. So your final answer would be 0.29. Multiplication division, in my opinion, is much easier. And you use it more. So that's awesome. Okay? You round based on the number that has the least number of sig figs. So here's two numbers. I'm going to multiply them together and get this gigantic number spewed from my calculator. And I'm going to write that down. And everyone in the scientific community is going to think I'm amazing. Because I did not measure that many digits. If you look at the two numbers you put in to the multiplication, you just have to go back and ask yourself, how many significant figures are there in each of my numbers that I use to calculate? The top one has 5, the bottom one has 4. You round your final answer based on your numbers that you put in that has the least number of significant figures, which means in this case, you will round to 4. You round to 4, that 1, the 4, the 2, and the 4 are all significant, and that's where you round. Here's another example. I'm going to divide those two numbers. If I divide those two numbers, this is what my calculator gives me. Thank you, calculator. That is not your final answer. You have to go back and count. How many significant figures does the top number have? 5. How many does the bottom number have? 2. You now need to round your final answer to 2 significant figures. So you look at your answer. The 0 is not significant. The 2 is. The 9 is. You check the number after the 9, which is the 1. And based on that 1, I don't need to round my answer up at all. So I would just report 0.29. It really is as simple as that. It's just a question of practicing. Okay, in my opinion, you will get these rules, you will feel comfortable with the rules, but if you don't apply them enough, you will make mistakes. You gotta practice. You gotta just keep practicing until you get it right. Go ahead and do the form and have a nice night.